Today's multiplication strategy is about using place value of each particular number in order to multiply. A lot of you will find that this strategy is very similar to using arrays and breaking apart because we are still breaking apart the numbers into more manageable parts, except that now we're not using a picture anymore. So 9, since 9 is a basic fact, I do not need to break up my 9. I can leave it as is. If I didn't know my 9s very well, then of course I could break it up into easier, more manageable parts, but it would take a few more steps. So in this case, I want to break 86 into its place value parts, which are 80 and 6. And the reason that I break it up by place value is because since 8 is in the tens place, that gives me a really nice, easy equation because it ends in a 0. And I know that anytime I multiply a number by a multiple of 10, there's got to be a 0 on the end of that number. So now I can write two easier equations. I can write 80 times 9 and 6 times 9. Because I've got to make sure that I multiply the entire 86 by 9. So I've got 80 times 9 first, and then the remaining 6 times 9 second. Well, since 80 times 9, 80 is the multiple of 10, so it's going to end in a 0. And then I've got 8 groups of 9, which is 72. So that's 720. 6 times 9 is 54. Now, I've got two partial products once again. You hear that word partial products just like when we talked about using arrays to break apart. Partial products, we call them partial because they are different parts. It is not the whole product in one move. It is partial products. So we're solving them in parts. Now I'm going to add up my partial products for a total of 774. Let's look at another example. In this case, I've got 64 times 12. Now, you might be thinking that both numbers need to be broken apart, but if you look, you'll realize that 12 is actually one of my basic facts, so I really don't need to break 12 apart. I can leave it as is. So now, I'm going to break apart the number 64 into 60 and 4. This is going to give me the least amount of equations possible while still making it easy. Now, I've got 12 times 60. And I still need to solve 12 times 4. 12 times 6 is 72, but it's 6 tens, so it's going to be now 72 tens. And 12 times 4 is 48. These are my partial products. They both make up the one whole product. So I'm going to add them together for a total of 768. My next problem is 16 times 7. Now I could do this two ways. I could break it up by place value, just like we've been doing, into 10 and 6. Or, let's say I didn't know my 10. That's funny, right? We obviously would know our 10s. But I could also break up 16 into 8 and 8 and solve the problem 8 times 7 twice. Now, obviously, I think multiplying by tens are much easier because they're basic facts with those zeros that belong on the end. So if I do 10 times 7 equals 70, and 6 times 7 is 42. I've got 2 ones and 11 tens for a total of 112. Now I could also go back and double check by using this other breaking apart strategy by breaking 16 up into 8 and 8, and now I'm going to solve 8 times 7 and another 8 times 7, which are both 56. If I add 6 ones and 6 ones, I get 12 ones, and 5 tens plus 5 tens is 10 tens, and when I add those partial products together, I end up with 112 again. So now I know that my answer is correct. I've double checked it. Okay, last, let's look at if I have a number with 3 digits, more than 2 digits. Still works the same. My 1 is not really a 1, it is a 100. My 4 is not a 4, it's a 40. And my 3 is in the ones place, so it's 3 ones. All of these need to be multiplied by 5. 3 times 5 is 15. 40 times 5, well, that's a multiple of 10, and 4 times 5 is 20, so that's 20 tens. And 100 times 5 is 500. These are all my partial products, so I need to add them together, and I have a total of 715. See if you can come up with your own example now and solve on your own. If you cannot come up with an example, why don't you try 19 times 9?